we are now in a world where in engineering, the products that we are involved in developing, working on, are getting more and more complex. This is a Dassault slide, which I borrowed with pride. It's evidenced by the Renault cars. But whilst these products may look on the outside largely to have a lot in common, we're getting to the point now that on the right there, we've got systems of systems. So if everything's going to work together, you've got a lot more people involved in this network, trying to coordinate the different standards, the different requirements, and trying to develop these products and services as efficiently as possible. So I've cheated a bit, and this should work. This I made this little thing. This goes straight to the Dassault definition of what a virtual twin is as far as Dassault is concerned. So in short, there's the term digital twin, and then Dassault coined the phrase or the term virtual twin. They also use the term virtual twin experiences. And personally, I think that's the most useful term. So in simple terms, Dassault's position is that a digital twin could just be effectively a dumb model of a physical object. So I know in the US, they've effectively reversed engineered the B-2 bomber, I think, which was designed on paper, but they've now made a 3D model of it. That you could argue is a sort of a relatively dumb digital twin, not without utility, but whereas Dassault's point of view is coming at the other end. If you're engineering a product from the beginning, you want to have this environment where you're engineering, designing, specifying your products in a space that allows you to play through its in-use experience from the user's point of view, from the product's point of view as well, from its service life. So inevitably, that means simulation is actually right at the core of the virtual twin. The whole point, this is why I like the term virtual twin experience, is better than just virtual twin on its own. Because I can't personally think of a virtual twin as a thing, is what it seems to sort of allude to. It's a bit like thinking of the universe, it just gets crazy. Whereas virtual twin experiences, these virtual experiences that you need to play through your engineering processes and your development process as you go, that makes a little bit more sense. So, traditional stuff like stress analysis and dynamic simulation, model-based systems engineering, even things like rendering. If you've got your digital model, then you can essentially automatically have a set of algorithms that say, right, this is the engineering model, how do I turn it into a commercial model and generate my renderings? There's a lot of manual work typically in there, but if you've followed the processes to get your data into this virtual twin environment, then all of this is available to you. So that's what we're looking at. So we're essentially saying that a virtual twin is your data set, your digital data set that holds all the information about your product and allows you to replay these, to play or replay all of these processes. So if you think about it from a point of view of more of a traditional look, and this is massively simplified, but just from a point of view of giving an idea, we had an environment where you had design and development with simulation feeding in, but you had systems engineers, often paper-based, or even document-based, passing in information. And these arrows represent essentially barriers, and I guess this represents to a certain extent silos, really. And then manufacturing follows design and development. It always would overlap in reality, I know, but in simplistic terms, that's where we're sort of coming from. But that's left us in this world. So this was last week. I was at Dassault event, model-based systems engineering in Gothenburg. And there was a very nice gentleman from Kongsberg Aerospace and Defence, and they're a long way down this road of basically digital processes for the systems engineering side of things, model-based systems engineering. And one of the problems they're trying to solve is exactly this. You've got so much information on these complex systems. The more complex we're getting with things, you've got requirements, you've got models for systems models, you've got dynamic models, you've got stress models, you've got CAD models, documents coming out of your ears, and you end up to the point you've got to have this new role, which is effectively a system archaeologist, which is not going to be any fun for anyone. So one of the roles that Dassault is trying to do with this whole virtual twin thing is the 3D experience is effectively your digital repository of data, associated products. So if you've got this environment where your requirements, your logical architecture, physical architecture and products are designed in this environment, and you've got lots of people working together, doesn't matter what discipline they're doing, they've got access to what they need to see related to their product, then things are going to move faster, people are going to make better decisions, you've got all the information available. But you wonder why Dassault's invested so much in simulation, because it underpins everything going forward. But as I said, it's also a bit like Dassault giving us a sort of like a parent almost guiding us as a community towards doing the right thing. So by getting our data into a system, in this case 3D Experience platform, whilst we might not be doing model-based systems engineering yet, and we might not be doing digital manufacturing, they're saying to us, we're going to curate and structure your data, if you use this system, in such a way that when you do start doing this, and customers and suppliers are going to get you to work with them in this way, then this system is going to support it. That's what I'd like to think anyway. So I'm going to give a quick whistle-stop tour of something just to illustrate some of this. And this is usually a 20-minute presentation on its own. Sorry, Mike. But I'm just going to basically just shout out the slides at you and just to show you some of this. And I'm upstairs in room 1 in the breaks, and more than happy to go through this in more detail. But this is a high-level view. But essentially, this is Kongsberg, the same company this gentleman was from, Aerospace and Defence. They've done quite a lot of this. And this was our colleagues in Sweden did an end-to-end expose, if you like, to the senior management using a real product. So this is just a quick, does the video play by itself? Yes. So that's 3D Experience. So this is a CAD model of, this was a student project, but the data is less important than the story it's telling. So the nice thing about this is an autonomous drone, completely harmless, that, sorry, I had to put a bit of context there. You can see you've got the model for general information review. There we've got a simulation model of the same thing. And then we've got a manufacturing work instruction model. And the average person in 3D Experience can get hold of this data, view it, interrogate it, without going to the analyst, without going to the manufacturing engineer, without going to the CAD engineer. So I'm going to skip a little bit on that because there's more on that later. So you start at requirements. So on the platform, we've got requirements stored as database objects rather than documents, even though we've got a friendly view that looks like a document. So that's good. If you've got requirements stored as database objects, they can be shared between different people or stakeholders. They can be in different lifecycle states. They can be revisioned, and you can configure requirements. So if you have a product, like a superset of requirements, and that product comes in 3 variants, you can filter those requirements down depending on which product that is. Collaboration at this level, until last week, I was thinking, why do you need to do that? And then you speak to Airbus and BAE Systems, who are doing another type of autonomous drone, which talks to flying radars and all manner of things to do things. And you can see that systems gets very complicated, which brings us on to functional models. This is inside CATIA, but there's other tools that can be used to do this and then integrated with the platform. So what does it need to do? How should it work? Logical. How do you actually separate the product into modules that do certain things? So on the left, we've got the RFLP tree, which has been in native 3D Experience since it was there when I looked at it in 2009. So requirements, functional, logical, physical, which you'll see in a second. So behind these could be mathematical models that simulate the performance of that particular module, whatever it might be. And the spoiler alert is that this can all be played in the platform using those mathematical models. You can have the CAD models moving around doing whatever it is you need to do. You can even have physical bits of hardware plugged into the platform, and instead of driving the model, you can actually drive the hardware with the software integrated into it. This is all absolutely present, and we saw all of this last week working, which I'll show a bit more. And there's the CAD model. The nice thing now is that each object of the CAD model is linked back to the objects in that you've previously defined. So what requirements are they satisfying? What logical objects do they represent? Or functional objects do they represent? Simulation model. Will it break? Red is bad, I'm told. And then you've got your manufacturing model, your work instructions. So in the full version of this, we actually go through a process of saying, okay, design change come in. So I'm just going to trail that a little bit. So here we've got requirements. So this is a CATIA screen showing this whole MBSE style traceable tree, effectively. And so in CATIA, you can go to the requirement, and not many people know this. And so in this case, we've got a requirement where a logistical landing, gentle, they want to be able to do a tactical landing, which is essentially a controlled crash, faster landing. So if you're going to do that, instinctively you say, oh, I've got to upgrade the landing gear. But what does that impact? And so this is effectively a map of your 3D experience platform, your product in the 3D experience platform. This is the system's traceability. So because you've put your data into an organized structure, you can click on the requirement and it shows you all of the downstream things that trace back to that requirement. So if you're changing the landing speed, essentially, this should show you all the bits that need attention that are impacted by that. So the whole idea of virtual twin experiences comes back to, frankly, getting your data into a manner that can be managed and used to be able to run these experiences, whatever they may be. It could be just essentially putting on a virtual reality headset and doing 3D, 3D experience, say no more. Or it could be quite complicated end-to-end simulation processes involving hardware in the loop, software in the loop, user in the loop, or whatever it is. As I said, if you want to find out a bit more about all this, please come upstairs and I can show some of this upstairs, or by all means talk to me or any of my colleagues who will fill you in as best we can. I'll say that specifically the model-based systems engineering side of things is, to me personally, is quite a new thing, so I may well get other experts involved. So as far as I said, I'd say give a bit of today and tomorrow. In terms of where are our customers at the moment, 3D Experience Cloud is seeing accelerated adoption. These days, it literally is about 10 to 1 between people taking on cloud versus on-premise. On-premise still remains the ultimate flexibility for people who've got very demanding business processes or demanding security requirements, like the MOD might insist that you have your data on site, whereas cloud is inevitably hosted somewhere. In our case, it's usually in Paris. But cloud is accelerating. It's starting to become clear what Dassault are doing with it in terms of integrations, which are absolutely vital for virtual twin processes, ultimately. And they're introducing some new cloud-only applications. So things like change intelligence, issue intelligence, weight and balance, sustainability. These intelligence apps are all, some of them have twins on premise, but they use a different technology, whereas on cloud they're using this new what they call the semantic graph index, which is another acronym I'm going to have to remember, which is really next generation stuff. Again, we can talk about that more separately. There are also, of course, standalone products which customers are using, which I think feed into the story that we've just been looking at. So Abacus, for instance, is now, since we were here in 2019, some of us, Abacus is now integrated within the platform, including cloud, in so much as you can connect to the platform, store data, and run jobs in the cloud rather than locally, if you wish. Dymola, not my area of expertise. I'll defer to Mike and co with that, but and the Claytex guys. But some of that technology is within what you've just seen inside CATIA and the platform. And then CATIA Magic and Cameo, which is a product that was looking at last week for requirements and systems engineering. That's another thing. So these are all products that are part of the Dassault suite and are either already or becoming more connected to the platform. And so all of these things are going on at our customers. CAD, obviously, Altium, electrical CAD integration, manufacturing, bill of materials and process planning on the platform. That's all going on. Work instructions, FEA. And right at the bottom, integrations, specifically lately on cloud, which is a big step up from, again, when we were here in 2019. Integrations with other systems was something you couldn't do on cloud. Now there's an entire framework on the platform for doing that. And we've got customers, we've worked with customers to develop integrations with things like ERP systems and Jira and other things, all web services, and fantastic. So we have quite a few customers presenting here who are going to come from, it's going to come from their mouths what they're doing, so you'll be able to see and validate all of that. So just a few thoughts of mine, which just to finish on, which I'm not saying these are officially sanctioned Dassault announcements, but these are things that I can see coming, and if they don't come, you can sue me. Model-based systems engineering, well, you can't sue me, but caveats apply. But it's obvious. Model-based systems engineering is getting more closely integrated. Simulation roles are packaged with CATIA roles these days in the M3K, M3S. You're going to see more of that. It's getting closer together, because if the idea of a CAD role, graduates coming out of university, when I came out of university, I'd done FEA, and that was a long time ago. So if you've got people coming out of university and you're not giving them access to all these tools now, then it seems foolish. So that's reflecting reality, really. Product structuring. I know we've got customers in the room who are doing configured bills of materials, and we've got the unified product structure. There's some exciting stuff our German colleagues are working with Dassault on how product structures can be approached and handled in very, very complicated cases, which is looking extremely interesting. I've mentioned index-based apps. The idea of these index-based apps is that you've got the platform. Oh, it's a fixed data model on cloud. That's a shame, out of the box. You've got this index on top, which is not fixed. This new technology allows you to effectively define your own index, your own repository of information, and your own apps to be able to access and navigate that information. So Dassault's strategy there seems to be becoming a bit clearer. Out of the box, structured database for CAD management, structured processes like change and that sort of stuff. And then this sort of zone at the top here, these index-based applications that are more business customizable or configurable, sorry, that's probably the right word. The integration framework, which is available on cloud and on premise, just continues to be developed. There's more APIs available, tasks, issues, BOM objects and so forth, shapes, import, export. So that's going to continue to become richer, and direct integrations, i.e. only having data in one repository but viewable from others rather than duplicating data, absolutely pivotal to the future. We don't want to copy data from one system, paste it into another, and have to keep it up to date. You should be viewing on demand where you can, and that's becoming a lot more doable. And then hopefully people like us are going to be able to offer more to help where there are gaps, or where there's needs to be, where Dassault go so far, and then you've got options to how you pick up from where they pass the baton. We're working on software, especially around integrations and out-of-the-box configurable add-on products like widgets and things like that, so that you can adopt and get the best of the platform more quickly. So I'm going to finish as I started. Somebody sent that picture and put the blue line on it. So systems engineering humour, does anyone get it? V model? No? All right, bit more work to do. Anyway, on that note, I will say thank you very much.